Okay, guys. We are picking up where we left off yesterday. So I believe we're ready for J. I don't know. What do you guys remember? How do we take the derivative of y equals x to the fourth sine squared x?
4x to the third sine squared x.
Okay.
That's as far as I got.
Okay. I can agree with that so far. Okay. So the derivative of x to the fourth is 4x cubed. Yes. And then what do we do with sine squared x? We're going to keep it as is right now, because what rule do we need to apply here? This is a product, isn't it? So I know I was teaching chain rule yesterday, if I recall. That's what this whole lesson was about, right? Making sure I'm in the right track here. So we're talking chain rule, but we still have to apply product rule in there. And I don't remember, did we get to any others where we had to do product rule?
No.
I think this is maybe the first example. We're doing lots of chain rule, but here we have to do the product rule. So the derivative of the first, derivative of x to the fourth is 4x cubed. Keep the other one the same. Product rule we add. And now we're going to keep x to the fourth. And we're going to do derivative of sine squared x. What?
I want to say cosine squared, but I know that
No.
2 is the...
Right. So you've got to remember that, and I didn't write it here, but sine squared x is really the same thing as saying sine x to the second, yes? So for that sine squared x, we have to do the power there. So take the 2 out front, right? So 2, keep the inside the same. So 2 sine x. The power on sine x is now 1, because 2 minus 1 is 1. But then it's times derivative of the inside. So derivative of the outside was using the power of 2, moving that around. And then derivative of the inside, so what's the derivative of sine x? Cosine x. And then officially, if you want to think chain rule again, I keep saying we've been doing chain rule, and that's times the derivative of the inside. What's the derivative of x? 1. Okay, so that's why we can always do chain rule. It's just we don't have to worry about it when the inside is just x. Okay. Cleanup. About the only thing I would say is on that second term, put the 2 out in front. I was looking to see one option I have written in my notes is that y prime is 4x cubed sine squared x plus, and then if I put that 2 out front, it's 2 x to the fourth sine x cosine x. You could leave it like that. The other option would be what? There's a GCF if you wanted to factor it out. I say if. There's no, this is what we always definitely do. So you could leave it like that, or we could factor out GCF. And if we factor out GCF, what do both terms have in common? A 2 x to the third and a sine x. Okay, so if I divide by 2 x to the third sine x, my first term is going to be left with 2 sine x, because I just divided away 2 and 1 of the sine x's, plus my next term is going to be left with 2's gone, we still have an x, sine's gone, we still have a cosine. I don't even remember what was in the key for this. Again, just be able to manipulate it however you need to. Okay, ready for K? H of x equals natural log of x. So we have a log within a log here. So I'm trying to find h prime of x. Remember, it's the derivative of the outside times the derivative of the inside. So what's my outside function? Outside is natural log of something. Okay, so we're trying to take the derivative of natural log of something. What's the derivative of natural log of something? 1 over, normally we say x. If it's derivative of natural log of x, it's 1 over x. Since it's the derivative of natural log of something, I'm going to say 1 over something. What is my something? Ln x. So we're going to do 1 over natural log of x. That's the derivative of the outside times the derivative of the inside. What's the derivative of natural log of x? 1 over x. Okay, so that's that chain rule at work. So when I clean this up, I can write the derivative of h as being, I would just multiply the fractions together. Ln x times x, put the x out front and say x ln x. So 1 over x ln x. Okay. L. F of x is sine of e to the pi x. Okay, what's first? Okay, derivative of sine of something is cosine of something, right? So derivative of sine is cosine, keeping the insides the same. Then it's times the derivative of something. What was my something? E to the pi x. So what's the derivative of e to some power?
The power of
No. E to some power, right? What's the derivative of e to the x? Itself, right? E to the x. So what's the derivative of e to the pi x? Itself. E to the pi x. So the derivative of e to some power is e to some power. Am I done? No, because now we've still got to do the derivative of some power. If it was just x, it'd be fine. But what's the derivative of pi x? Pi? Because pi is a constant, right? So it's kind of like saying what's the derivative of 5x? Derivative of 5x is 5. What's the derivative of pi x? Pi. Okay. Nothing to do other than clean it up a little bit if we wanted to. A more typical way to write this would probably be saying pi e to the pi x times cosine of e to the pi x. That would be probably what you would see written. Okay, M. I want to rewrite this one before I start the derivative. Personal choice. And why am I rewriting it? Because there's a squared there, yes? What is that squared on? The cosine, yes? Is it on the 4? No, it's on the cosine. So I'm going to rewrite this as 4 times, I'm put it in parentheses or brackets, cosine of pi theta raised to the second. Now, I don't know, do you need me to rewrite it like that? Not necessarily. I'm not sure where you guys are at. But in all honesty, sometimes I see it better that way. Okay, ready to do your derivative? Okay, what are we thinking? What's my outside function? Something raised to the power of 2, yes? So how do I do something raised to the power of 2? Okay, multiply the 2 out front, so that 2 times 4 is going to be 8. Keeping the inside, so keeping cosine of pi theta. And then cosine of pi theta, when we subtract 1, is now raised to a power of 1. Times what? Okay, so it was something raised to the second. So that something was this cosine. So now it's the derivative of cosine. Derivative of cosine of something is negative sine of something. And make sure, I know I have my multiplication out there, make sure that it's not just a minus sign, right? Because otherwise it could start looking like subtracting, and it's not. Anything else? Times pi. So the derivative of cosine of something was negative sine of something. But then what's the derivative of pi theta? And that is pi. Okay. Have you figured out how I'm going to clean this up? We have that 8 out front. What else am I going to take out front? The pi and the negative. So I'm going to say negative 8 pi. And what do I have? Just a cosine and a sine? So cosine pi theta, sine pi theta. And I would probably leave it like that. Okay. In tangent of the square root of 2x minus 3. Now, be careful here in how you think about this, but if your brain needs to, what do we know about a square root? That is a 1/2, isn't it? Now, is this the square root of tangent? It's not the square root of tangent. It's just the square root of that 2x minus 3. Okay. Okay, the derivative of tangent of something is secant squared of something, right? I'm not going to write secant squared x, so I'm going to write secant squared of this square root business. Okay? Because in other words, the inside stays the same thing. So the derivative of tangent of something is secant squared of square root of 2x minus 3, if you want me to write it like that. Okay, so when you do those trig derivatives, the inside part stays the same. So derivative of tangent of something is secant squared of something times the derivative of that something. How do I do the derivative of 2x minus 3 to the 1/2? That's our power rule, right? So 1/2 moves to the front, keeping the inside the same as 2x minus 3. 1/2 subtract 1 puts me at negative 1/2. And then times 2, right? Because it was something raised to the 1/2. We did that. Times 0 to the inside, so times 2.
Why did the 1/2 not affect the derivative of tangent?
Correct. The derivative of 1/2 did not affect the power of 1/2 did not affect the derivative of tangent because it was tangent of that piece right there. And maybe that would have helped if I would have, it's tangent of that square root. So the derivative of tangent of a square root is secant squared of the square root. Then we do the derivative of the square root, and then the derivative of the inside of the square root. Okay? Let's see. 1/2 times 2. Those are going to cancel each other out, right? I know how I'm going to write this. I don't know if you guys see it. There's a secant squared square root of 2x minus 3, yes? What about this 2x minus 3 to the negative 1/2? It goes to the bottom, right? So I'm going to write this as secant squared square root of 2x minus 3 on top over regular square root of 2x minus 3 on bottom, or 2x minus 3 to the 1/2. It just felt weird putting 1/2 when I already have a square root in the secant. I cannot.
Why?
Because this square root of 2x minus 3 is the variable in secant. So, I mean, if I have secant squared x over x, x's can't cancel because this x is the inside of the secant. Make sense? We want to cancel it. You know, clean up so nice, but you can't have secant of nothing, if that makes sense. Okay? Last page, these tables. I love how these tables practice. Okay, I know the tables may get annoying, but I feel like we see a lot of tables on AP. And so I feel like you guys are going to be prepared in at least not being shocked when you see a table, knowing ways of how to deal with it. So, okay. Let f be a continuous and differentiable function on the interval from 0 to 1. Let g of x equal f of 4x. The table below gives values for f prime of x, the derivative of f of x. Find the value of g prime of 0.2. Okay. So we need the value of a derivative of g. So I would start here with the fact, what was g defined to be? G of x is defined to be f of 4x, correct? Not that you couldn't, but personally, before I ever put the value in, I want to take the derivative of g. Okay, because we're going to evaluate at 0.2 later, but I want to know what's g prime of x going to look like. Derivative of f of something is going to be f prime of something, yes? But where am I going to go with this?
You're going to multiply by 4.
Times the derivative of something, and the derivative of 4x is 4. Okay, so whenever we're talking in g's and f's, and you have the value inside there, that's our chain rule, okay? Now, we're going to be doing g prime of 2/10, yes? So g prime of 2/10, I would say every place I see an x, I'm going to put in a 2/10. So then I'm doing f prime of 4 times 2/10 times it outside 4. 4 times 2/10 is 8/10. You guys with me? So now I have f prime of 8/10 times that constant of 4. And what is f prime of 8/10? Okay. Right here, guys, on the chart, yes? So 1.125 times 4. 4.5. Okay. 2 more. New table. Use the table to complete the following. Find the equation of the tangent line to x equals -1 if h of x is 3f of g of x. Well, we need to write the equation of a line. The slope? Okay, the slope, which is going to be the derivative, and then we're also going to eventually have to have a y value, right? We have to have a point, yes? We need a slope and a point. So, as it was brought up, in order to do slope, right, we need to do derivative. So we need to do h prime of x. So the derivative of 3 times f of g of x. That 3 is a constant out front. Just put it there, okay? Derivative of 3 times something is 3 times f prime of g of x, right? So derivative of the outside times, then what? The derivative of the inside. So derivative of g prime of x. So that's what your derivative looks like there. Where do we need to know about this derivative? At -1. So 3 f prime of g of -1 times g prime of -1. So I just filled in -1s for my x's. Look at your insides there, right? So because it's a composition, 3 is staying 3. F prime is staying F prime for the moment because I have to figure out the inside value. What is g of -1? G of -1 is -1. And then we can go ahead and do what's g prime of -1? 2. So I have 3 times f prime of -1 times 2. So 3, what's f prime of -1? Times 4 times 2. 3 times 4 is 12, times 2 is 24. What is that 24? That is my slope, yes? It is h prime of -1, but more importantly, it is my slope. Okay? Besides slope, I also need an ordered pair. Right now, I know my ordered pair is -1 comma something. How do I find that? Yeah, we're going to plug -1 into regular h. So we're going to do h of -1 is 3f of g of -1. So don't take the derivative here, just use the given function. 3 times f of g of -1. What's g of -1? -1. So then it's 3 times what's f of -1? -2. So h of -1 equals -6. And we have the ordered pair -1, -6. I'm listening too, that's why I was trying. Okay, am I done? Not if you want to go all that way and only get partial credit. Equation of the tangent line was the request. Y equals 24 parentheses x minus -1, so x plus 1 minus 6. You can manipulate that equation as necessary, correct? Because you never know what form they will give it in. Okay. Lots of compositions here. So lots of chain rule. One more. If j of x is f of g of x times cosine x, just to, keep it interesting. What is j prime of 0? Okay. Well, I'm going to start by finding j prime of x. We obviously see the chain rule that's going to happen when we do f of g of x. What else? What other rule do we have to use here?
Cosine.
Yeah, there's a product rule here, yes? It's not just going to be derivative of the first and derivative of the second. We've got to use that product rule along with the chain rule. So, if we go derivative of the first, keep the second. Derivative of f of g of x is f prime of g of x, derivative of the outside, times derivative of the inside. So f prime of g of x times g prime of x, that's derivative of the first, keep the second. So derivative of the first, keep the cosine x. Product rule says to add, and this time we're just going to keep f of g of x times the derivative of cosine x which should be negative sine x. Okay. We're plugging in 0. J prime of 0 is f prime of g of 0 times g prime of 0 times cosine of 0 plus f of g of 0 times negative sine of 0. What if I say I don't even have to worry about one of these sides? Do you see it? I have a cosine of 0 and a sine of 0. One of them is 0 at that point. Make sense? And which is that we know? Sine of 0 is 0, yes? So what's all that piece going to become? That's going to be 0, isn't it? So can I just not even worry about f of g of 0 here? That's my opinion, because, you know, f of g of 0, it's not like I'm going to get a does not exist or anything crazy. I'm going to get a numeric value up there, so why mess with it? Save myself a little bit of work. Okay, f prime of g of 0. Keeping the f prime, what is g of 0? 2 times g prime of 0, which is negative 3, times cosine of 0. Do we know cosine of 0? 1. And then I don't have to worry about this other part because it was all 0. So then the only thing I have left to worry about, f prime of 2. Negative 2 times a negative 3 that was already there times a 1. Negative 2 times negative 3 times 1. 6. It even matches my answer key. Yeah, I can't underline that there. So we'll just leave it as 6. Okay. Some of these are big, right? There's pieces. You have to keep your head on straight. That's the only, you know, it takes work. I get it. Okay. I know the homework might even be longer than the notes, honestly.
35. 30.
I know. Hey, but there's this weird thing happening.
We have class time.
We have some class time. So,
We should do evens and odds.
Can we listen to the song while we do our work?